not.
All right. I want to change this conversation up a little bit because we have, like Gabriel said, the guy who created the C chain, which this is, when we talk about the history of Ava Labs, when I joined, yeah, literally you were the C chain guy. This blockchain, which is now basically top 10 in the world, that has many $1 billion of assets on it, was kind of created by like one guy. When, I mean, honestly, the X chain was like the team's first priority back in, late 2019 or late 2020. And you were the C chain guy. Now there's the whole platform team of like 15 people that work on various parts of the C chain.
20 now, actually. We're still growing.
20.
Yeah.
They won't let me hire anybody. My God, they just take them all for themselves.
Yes.
But yeah, you have like incredible technical expertise on the C chain, and you've been working on some really cool stuff that we wanted to highlight. And so the first thing I think we should touch on is this new feature that we've added. So you've also been deeply embedded in subnets, but the first kind of the most popular subnet that we see in the next few months is going to be our Subnet EVM, which is basically standing up your own copy of the EVM whenever, with whatever changes you want to make.
Yep. There's the PR from today. That's the feature we're going to be talking about, that last commit right there.
Yeah.
There it is, number 31.
When you create a new version of the Subnet EVM, you can make changes to the EVM. And when some people ask, well, what changes would I want to make? Well, there's one particular change that you added. I forgot what they called. I forgot what it's called. So why don't you take it away and tell us about your stateful precompiles?
Yeah. Stateful Pre-Compiles is what I've been calling them. This is actually something that we kind of came up with a while ago, but we just kind of realized that we could use it in a much more interesting, much more powerful way. And so that way is probably going to be in creating new custom VMs built on top of the Subnet EVM. And just to correct one thing here with Subnet EVM is we're realizing now a bit of a misnomer, because when you create a subnet, you can deploy an instance of a virtual machine to that subnet. And we're realizing now that a lot of people see Subnet EVM and they think that is the subnet, but a subnet is actually a validator set as well as a group of blockchains that are validated by that validator set. So we might need to change the name of this. It might be a little bit too late to do that. But just to clarify one thing, Subnet EVM is a virtual machine that runs a blockchain, so it runs on a subnet. You can actually have multiple different instances of the Subnet EVM on one subnet. So we'll see if we decide to put in a name change there, because I'm not sure that's very clearly communicated. But yeah, so the interesting thing that we've been developing is stateful pre-compiles. And so this derives from the notion of precompiled contracts from Ethereum and their version of the EVM. And so what the precompiles are in the EVM is it's a way to do mostly complex cryptographic operations outside of the context of Solidity. If you're trying to do a BLS signature or just verifying any kind of signature or some hash operation, to write out how to do that in Solidity would be extremely expensive and also very, very complicated to write in Solidity, and nobody really wants to do that. And so the notion that they developed is this concept of a precompile. And so what it is you can pass in some arbitrary input data and to some address in the same way that you call a contract or a smart contract in the EVM. And so it passes that input data in and it returns some value, which is usually a hash or their signature verification or some crypto operation. And the reason they do this is it would be very expensive to do in Solidity. So they made this easy for everyone. It's a really useful utility for lots of different kinds of smart contracts. So what we did in order to implement stateful precompiles is we added in state access to these precompiles. So for the crypto operations, they obviously don't need any access to the state. They don't need to read anything from the state. They don't need to write anything. But once you actually provide access to state to that interface, then you can start to implement lots of different things. And so this is going to be really, really interesting for everybody that wants to have their own instance of the Subnet EVM if they want to have some level of customization. Because once you have that, you can do various state operations and you can do them entirely in Golang. And so that becomes really cool. So what we did this week, or the past couple of weeks, was we implemented a stateful precompile and built out an interface for it and made it as easy as possible for people to build new ones. And so the first one that we created was an allow list, which is a list that basically says, does this person, does this address have rightful access to this resource? And so we implemented this specifically for some of the people building on Subnet EVM that are launching their own instances, largely in GameFi, where they want to make sure that they are the only people that are going to deploy a contract to their chain. If you're launching some game to a subnet, you don't want to compete with anybody else's project on that subnet. You literally just want to create it for yourself and for your users, and then have some connections back to other ecosystems. Well, you want to control it yourself. So what we did is we created an allow list for contract deployers. So what this does is only your set of admin addresses, you can see there, that's the EWA key starting with 0x8db. Yep, right there. And so only that address will be an admin for over this allow list, so it can configure new people, enable them, as well as add new admins, remove admins, etc., or make it so that people and anybody not on this allow list won't be allowed to deploy a contract. So this is a really powerful construct for a lot of the people building on Subnet EVM right now. And once you have this kind of interface where you have access to state, there's really no limit to what else you might be able to build. And so the way that we actually made this is that if you pull up in precompile allow list.sol, actually, if you just scroll down in the screen, I think it's below this, you can see that there's actually an interface to this precompile contract. And so what you can actually do is just create the interface in Solidity and then implement it entirely in Golang. So this allow list interface is implemented entirely in Golang, but you can still deploy this or use this interface and deploy this to Remix and interact with it entirely from there, or any other tooling that you want. So previously precompiles, you just passed in input data. But now what we basically did is we make it so you can create these functions and actually make Go programs execute behind them with that access to state and do whatever you might want. The only requirement there really is that they have to determine its executions, that different validators running the same code don't end up with a different result, which would obviously break consensus, because people would execute the same thing and arrive at a different result. And the way that this works is essentially when you have a smart contract built in Solidity, it has to, when you execute that smart contract or send some input data to it or interact with it, do a smart contract call in some way, the way that it determines where to jump to in the code is by using what's called a function selector. And so that function selector is the first 4 bytes of the KESIC 256 hash of the signature. And so what we do in this contract is we have the input data, and what we do is we check to see the first 4 bytes, and we check for any matches to function signatures that contract is implemented. And so if we find one, we can use that execution function. And so once you have that, you can define whatever arbitrary logic you want, implementing an exact interface. You can have multiple different functions on one precompile, and you can essentially implement any type of smart contract that you might want using this interface. So it's really pretty powerful. And what we're really expecting and hoping for is that anybody that wants to launch a Subnet EVM, but they want to have some slight modification, is going to get a lot of value out of this. Because if they want to launch some modification, they now have a very clear interface to write whatever function that they want, do literally whatever they want in Golang, and deploy that as a smart contract or treat it as a smart contract externally. So whatever utility the EVM is missing that would be useful for really any application, they can create that very, very easily out of this. So that's the goal. That's the hope, is that this is going to be an extremely usable, very, very easy to use tool for anybody that wants to customize the Subnet EVM.
Wow, that's great.
So one thing,
go for it.
I've never heard anybody pronounce it Kesak. I've always said Kekak. You could be right. I'm just surprised.
No, I'm probably wrong.
I've never heard anybody pronounce it any other way either, but it's just...
I don't think I've ever heard anyone, actually, no, I definitely heard people pronounce it. But it's one of those things I never picked up. And
yeah, so just... So to like kind of reiterate this, just to make it like super clear for our listeners. So yeah, so if you've ever coded in Solidity before, so these Solidity before, you might have used these functions, but yeah, so basically, all of the operations in a Solidity smart contract get compiled down to EVM bytecode. So it's just like when you write a C++ program, it gets compiled down to like x86 assembly for your machine. It's a series of small bite-sized instructions for like add, move, store this value, load this value. And constructing a big cryptographic operation would just be hugely expensive. And so these precompiles are a little cheat code where basically instead of running the function in the Ethereum virtual machine, it actually runs it on your like main computer to get the results so that you can do expensive things like compute a hash function or do a signature recovery. So yeah, if you've ever used, the KECAC 256 function or like EC recover, those are all precompiles. And so this tool expands what those precompiles can do and makes it, even easier to use them. And, what are some of these things useful for? Like, why would you want to expand this besides the allow list? When I was reviewing entries for the Morales hackathon, one of the proposals that I saw that I thought was super cool was one that introduced a random number into the block header of an Ethereum block. And so there's a lot of issues with randomness in smart contracts. And so this guy's solution was, let's include a verifiably random number in each block so that people aren't using like the block hash or something like that that might be gameable. There definitely is some gameability still to this. So I wouldn't take this solution verbatim, but it's just kind of an illustrative example. So you can actually, if you have this random number, you still need a way to access it because there's no Solidity native way to just say like, get me eth.random number, because it doesn't exist in mainline Solidity. There's no Solidity compiler that has the ability to grab this value. So you kind of have two options to do this. One of them would be you could modify the EVM to have an extra instruction and an extra opcode. But then the problem is you don't have you'd have to modify all of your Solidity compilers to support that operation. The alternative is you could do a precompile like Aaron just told us about. And then in your code, instead of having to do some like EVM assembly, you can actually just call a function and it's there. So if you have cool ideas to extend the EVM, like this is the way to do it. And you can do, this is, an instance where you can do more on Avalanche and Solidity than you can do on Ethereum now.
Yeah, so yeah, there was a few questions that came to me from that. The first one was, presumably this is not available on Ethereum, and I guess Connor just answered the question to that. The second one was, can you guys think of some examples other than cryptographic functions that you might want to do as a precompile? So that's one open-ended question. And then the last one was something that I've been super excited about, and I've talked about a ton in the past, and I was hoping that Aaron could maybe give us and explain it like I'm 5, is the ability to write VMs in non-Golang languages and use this gRPC API. So before we get to that one, are there other examples that come to your all's mind other than cryptographic operations that you might want to use this for? What other things do you guys expect to see?
Yeah, I think one of the most exciting ones, and I'm not exactly sure what the timeline is going to be on this because we are very busy working on lots of things. But one exciting potential opportunity is to have precompiles for atomic transactions. So right now on the C chain, atomic transactions are executed completely outside of the EVM. They are a foreign transaction type that we've basically injected into the block, and they're executed and verified separately from the EVM code. And so those allow us to transfer assets between the C chain, X chain, and P chain, and back and forth. So the interesting thing that we might be able to do is to use a precompile in order to support that same type of operation. And that if we can do that, that would be a really very cool, very, very cool thing. So we'll see if we can make that happen.
It's something really out there. I don't know how practical this would be. No, so I'm gonna throw something out. So like, I think this would be useful for anything that is like computationally hard, but would be significantly like repeated. So let's just say you wanted to do some like blockchain machine learning hybrid, and you had like a neural network on your subnet, and you needed to like run the neural network, which has an agreed upon state, like to classify an object or something like that. You could make the classify operation a precompile to remove that like compute heavy task from the contract. So you could do some crazy stuff like that. I'm not sure that's actually a good idea, but that's my crazy idea for the day.
Okay, very cool.
The cool thing about virtual machines is, you can implement them. You don't have to use the EVM. So I think the one thing there would be, it'd be very interesting to see what context you wanted to apply that machine learning algorithm to, and like why it would make sense to do that on top of the EVM or include it. And if you did that, and then there was some other ecosystem there too, that could be really, really interesting. And
I have no use case. I have no use case other than buzzwords.
Yeah, there are lots. Yeah, we can throw more in.
Is there going to be an easy way for people to share their precompiles? Will it just be through GitHub, or is there going to be some other way to do this kind of thing?
Yeah, so if anybody has an idea for a precompile, they can make a PR to the Subnet EVM. If it's something that's interesting, we can kind of assign it a canonical address there. And it can, the way that we're doing this is all of these precompiles are going to be optional. And so people can configure them in their chain config, deciding whether or not to enable them, as well as doing a network upgrade in the future in order to enable them. So for this, allow us, obviously not every instance of the Subnet EVM wants to have restrictions on contract deployers. A huge number of them, probably the majority, will not want that. They'll want to make it as open as possible, allow anybody to deploy a smart contract there. So that's obviously going to be optional. And if anybody else has new ideas, they can make a PR. We'll take a look at it, make sure everything works. And if it's something that the community wants, then we'd love to have more contributions to the Subnet EVM. If there's something useful, or if there's anything somebody wants, if they want to make a GitHub issue, we can see if we can build it out. And one of the cool things there is right now it has access to state, but the way that state access works is just a key value pair where both values are 32-byte hashes, which means that it's a little bit complicated to store something that's larger than that. So we are going to, in the future, if we want to make this interface more powerful, kind of take that capability and make it more powerful so you can store larger pieces of data and do more interesting things on top of that. So we'll see what we can do there. But yeah, if anybody has ideas, feel free to make a GitHub issue or pull request, and we'd love to build out more functionalities here.